Hello, this is FlippedHarber for Algebra 2. In this video we're covering section 6.3, dividing polynomials. Our objective for this lesson is to use long division and synthetic division to divide polynomials. Our outline for this video, we'll talk about how to perform polynomial long division, and then we'll talk about a process called synthetic division. Polynomial long division is exactly what it sounds like. When we take a polynomial and divide by another polynomial, we're going to use long division. Now, usually in this lesson you're going to be dividing by a binomial. But this isn't limited to just dividing by a binomial. This process can be used no matter what we're dividing by. Now, in order to be able to divide these, the power on the first polynomial always needs to be higher than the power on the second polynomial. So we have a power of 2, or a degree 2, divided by a degree 1. So we can do this. Now, I've set up with my first polynomial inside the square root bracket, excuse me, not the square root bracket, the division bracket, and the x plus 3 outside. Now, I know this is a pretty cheesy representation of the division bracket, but it's the best I had. Now, we're going to focus on one term inside at a time, and we're only going to focus on the first term on the polynomial outside. So we're going to take one term inside and divide by the first term on the outside. Now, obviously this plus 3 gets involved, but it is not part of our decision-making process. We start out by just taking x squared, our first term, and divide by x. We get x. X squared divided by x is x. Easy enough. Now we take this x and multiply it times this polynomial outside. X squared plus 3x. Now we subtract. X squared minus x squared. These first terms always cancel because of your division process. And now we go 2x minus 3x. I get a negative x. Drop this term down, minus 3, and now I'll take this term and divide it by x. So negative x divided by x is negative 1. Multiply by the binomial in front, I get negative x minus 3, and this time when I subtract negative x minus negative x, that always cancels, but also notice negative 3 minus a negative 3 gives me 0. Now, obviously I'm going to stop because I'm out of numbers. There's a more technical reason to stop, which we'll talk about in another example. But here we see my answer. When I divide x squared plus 2x minus 3 by x plus 3, I get x minus 1. Now, this one worked out perfectly. There was no remainder when we divided. In this one, there is going to be a remainder, and we'll talk about how we know when we stop dividing. Let's set it up with the first polynomial inside the division bracket, our 3x plus 1 outside, and again I focus on one term at a time and divide by the 3x. So 15x squared divided by 3x is 5x. Multiply that around by the 3x plus 1. Subtract, I have 3x minus 12. Now, because this still has a degree that's the same as this one, I can go ahead and divide again. 3x divided by 3x is 1. Multiply that around, and you'll see that it's not going to cancel like it did before. 3x minus 3x, yes, that goes away. This first one always goes away. Minus 12 minus 1 is a negative 13. So this one doesn't work out evenly. I know that I stopped dividing though because the power on x here is lower than the power on x out here. That's how I know when to stop when I'm doing long division with polynomials. When this power is less than this power. So this becomes my remainder. And here's how we deal with that remainder. We have 5x plus 1, and since our remainder was negative 13, it's minus 13 over the polynomial that we're dividing by. So minus 13 over 3x plus 1. And that's how you deal with the remainder. Now let's talk a little bit about a slightly different process called synthetic division. It's much easier than long division, but it's very, very limited. We can only use synthetic division when we are dividing by a binomial that is just x plus or minus a 1. If it's any more complicated, excuse me, not 1, some number, if it's any more complicated than x plus or minus a number, then we cannot use synthetic division. Here's a couple examples. We cannot use synthetic division over here because of this 4. If we are dividing by x minus 1, no problem. But because of this 4, we can't use synthetic division. We can use synthetic division over here because all we're dividing by is x plus 3. As long as we're dividing by x plus or minus a number, we can use synthetic division. Okay, so let's go ahead and run synthetic division on this division problem. Here's how I set up to do my synthetic division. I make this corner block, I call it, and what is inside this corner block is always the number opposite the number with the x. Since it's x plus 3, I put a negative 3 right here in the corner block. If it was x minus 3, I'd put a positive 3 right here. Right here we see the coefficients from the first polynomial. So this x squared has what's referred to as an understood 1, then the 5 from 5x, and then the 10. Now, every single term needs to be accounted for, even if we don't see that term. If this was x cubed plus 5x, that means there's no x squared term, so we would put a 0 for the x squared term. But we don't have any missing terms, so this is it, 1, 5, 10. Okay, now we're all set up. Here's the process. First, whatever this number is right here, this first number drops straight down. If this was a 2, I drop it straight down. If it was a negative 4, I drop it straight down. So whatever this first number is, it drops straight down. Now I multiply the negative 3, the number in the corner block, times this number, and it goes here. So negative 3 times 1 is negative 3. Add 5 plus negative 3 is 2. Multiply again and add. Now I'm actually all done with my synthetic division. This last number, whatever it is, sometimes it's a 4, sometimes it's a different number, sometimes it's a 0, whatever this last number is, that's my remainder. These numbers in front are the coefficients on a new polynomial, on my answer. This number right in front of the remainder is always the constant term, and then it goes on up from there. So this is the constant, this is the x term. So the 1 goes as a coefficient on x, the 2 is our constant, and the 4 is our remainder. And again, the remainder goes over the binomial that we're dividing by. So here's our answer for this division process. Okay, so now it's time for you to try some of these on your own. When it tells you to use long division, make sure you use long division. When it tells you to use synthetic division, make sure that you even can use synthetic division. Remember, only when you're dividing by x plus or minus a number. Okay, good luck. I'll see you in class and I'll see you online.